Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, I'm going to be dealing with pump stations. All right, so let's get started here. I've got HEC RAS up on the screen. We're going to start from the very beginning, File, New Project, and then go ahead and navigate to the directory you want to store your project files in. Okay, Project, and then give your project a title. I'm going to just call mine Exercise 13, click OK, and we're ready to roll. Okay, down below I have the geometric data editor open. So if you don't already, go ahead and click Edit Geometric Data. Click on River Reach, single left click to start the reach, sketch in the direction of flow, and then you can add some vertices if you want. You can add some curvature to the reach, and then double click to end the reach. Give that river and reach a name, and then we're good to go. All right, click on cross section. We're going to add a couple cross sections to this river reach, starting with the downstream most river station at 0. Okay, I'm going to start typing in some numbers here for the station and elevation, and that should look good right there. We'll see a preview of this cross section in just a moment. All right, for the overbank distance, I'm going to say 0 because this is the cross section at the very end of the channel. Enter the Manning's N roughness values. And then for the overbank, we're going to use 30 and 60. And then let's click Apply Data. All right, here is the cross section. And we're going to add a couple more. So I'm going to go up to Options, Copy. We're going to add one at River Station 100. Okay, so I'm going to change this downstream reach length to 100. And then also increase the elevation by a foot. So that will be 1% slope. Apply data, and then let's do that one more time. So I'm going to go copy cross section. This will be 200 river station. So just another 100 feet upstream. And as before, I will add another foot for constant 1% channel slope, which we can see from the profile plot here. All right, so with that data applied, I can close this and I see the cross sections right here. Next, what I'm going to do is add a pump station. So you see the pump station button right up here for tools. That's how you add a pump station. And if you wanted to edit a pump station data, it's the pump station button over here on the editors button on the left panel. So we want to add a pump station. I'll click on pump station right here, and then I'll just click anywhere on the map. Boom. Give the pump station a name. Pump station 1, and there is my pump station. I can also reposition this pump station if I want. Edit, move object or points. So this pump station is going to be extracting water from the channel or the river here at cross section 100. And I can move these elements, either the labels or the objects, in the geometric data display just so they appear a little bit better. Edit, and we're done with moving points and objects. All right, I'm going to go File and then save this geometry data. I'm going to name this geometry data 1 pump because we may add a second pump later. I'll click OK. And we need to actually edit the attributes of the pump station. So you can single left click on the pump itself or the pump station, click on Edit Pump Station. Or to get the same dialog box, you can just come over here to the button on the left, Pump Station, and boom, it opens up. If you click the button, you also may need to specify which pump station you want to edit, which is trivial in this case because we only have one. All right, for this first tab here, pump connection data, that's the tab it starts you off on first. We want to specify the pump inlet, and that's going to be this river station 100. So we'll click on the river station button, and then 100, and OK. And then for the tailwater, the pump outlet, that can either be another river station, storage area, type node, or out of system. I'm going to say out of system, but I could very easily have a storage area if I had sketched that in to use as a pump outlet. When out of system is used, I also need to specify a highest elevation in the pump line. So I'm going to just type in 220 right here, which should be a little bit above. Yeah, so that's a reasonable amount above the elevation here in the cross section. All right, back to our pump station data editor. The pump group right here, this is where we specify the pump curve as well as the number of pumps and their controls. So I'm going to start off with just one pump because that was the name of this geometric data file. And I'm going to say it has a 1 minute ramp up. And then for the on-off period, let me take a look at the cross section here. I'm going to say the pump turns on at a water surface elevation of 205, and then it's going to continue pumping until the water surface elevation is down to 203. So let's go ahead and give that a shot. Back to the editor, turns on at 205 and it turns off at 203. Keep in mind these elevations are associated with the pump inlet, which is river station 100. If I wanted to override that and set it to something else, then I could use this drop down right here. Okay, so back to the pump group data tab. Got the controls in, 1 minute ramp up and ramp down. Now over here, I'm going to specify the pump curve. So you can type the numbers in or you can just paste them in like I did right there. So we're going to have a max flow of 100 CFS, and then it's going to, of course, decrease as the head increases. I think the head is going to be around 20, so I expect the flow rate from the pump to be about 80 CFS. All right, we'll see what the results look like. We can preview the pump curve right there. That looks pretty good. Also, I can add additional pumps. This is a pump group called Pump Group 1, which I can rename right here, but I'm not going to. I can also rename the pump itself. I could just call it key 1. And if I had a second pump, I could just add it here, call it key 2, and then add the on-off controls in its own row. I'm not going to do that though. We're just going to see if one pump runs first. So I'm going to change that 2 back to a 1. And then there's also a tab here for advanced control rules where you can do different triggers based on water surface elevation, flow, time, and we're not going to do that either. Let's just carry on with what we have here. And okay. All right, we have our pump station in place. This line right here indicates the direction of flow as well as the inlet location for the pump. And I'm going to do a file, save geometry data. The next step in the exercise is to define the unsteady flow data. So I'm going to go up to Edit, Unsteady Flow Data, and then I'm going to start off by calling this Save Unsteady Flow Data. This is going to be 50-500-50. So what that means is it's going to define the hydrograph, which is the upstream boundary condition, which is going to range from 50 CFS, go up to 500 CFS, and then back down to 50. I'm going to change the time step here to 10 minutes. And then I'm going to highlight all these cells and then Control V to paste, which is the hydrograph I had saved on my clipboard. And it looks like it came in fine. Okay, so there it is, starts at 50. I can click this plot data and you can see what I described. It starts at 50 CFS and then goes up to 500 CFS and then back down to 50, where it maintains that base flow for another day or so. I'm sorry, this is just a 12-hour simulation, so it's going to take about 3 hours to ramp up, 3 hours to ramp down, and then the remaining 6 hours is going to just be this base flow of 50 CFS. All right, everything else here is fine. We're just going to enter the table data, use the simulation time, and then go from there. So I will click close here. Also, I need to define the downstream boundary condition, so that will just be using normal depth. And remember that our channel slope is 1%, so I'll just use that and click OK. The initial conditions tab is optional because I'm just going to rely on the boundary conditions to get that initial water surface elevation correct. All right, I'm going to go File and then Save Unsteady Flow Data. Now let's go ahead and create a plan and run the simulation. So I'm going to close this, click on this running stick figure running up a hill. That's the same thing as going run unsteady flow analysis. I'm going to name this plan file just a combination of the geometry file and the unsteady flow data so I can remember what the plan is just by looking at its name. So I'll go File, Save Plan. And then if I drag this down a bit, I can just see what I'm trying to type. All right, just like that. One pump, 50, 500, 50. Okay. And then same for the short ID. Now what I want to do is run the geometry preprocessor, unsteady flow simulation, and post processor. This is a 12-hour simulation, so for the date start time, I just need to make sure that it's 12 hours in duration. So what I've been using is January 1, 2020, and it'll start at midnight. And then for the end date, I'll say the same day, 12 hours later, noon. Down below here for computation settings, the 1 minute interval is fine. And then for the hydrograph output, I actually want to change this to 10 minutes because that is the same time step as the hydrograph. And then as for detailed output interval, I think I want to change that to 10 minutes as well. All right, let's go ahead and save the plan and then hit compute and see what happens. Okay, so that looks successful. I'll click close. Let's go ahead and look at some of those results. View, and then what I'm going to do is go profile summary table and then change this table to pump stations. And I also want to change the options to include all the profiles. So I'll just say select all and OK. Okay, so I'm looking at the flow rate through the pump station and I don't see any flow. It looks like the water surface elevation never got up to 205. I believe this is the maximum water surface elevation right here at 204.42. So that's a little disappointing. Let me go ahead and just confirm that by looking at the cross section, and that appears to be the case. So I'm at river station 100 here, and I can animate that simulation. And let me do it a little bit slower here. So I'm going to make it a little bit slower and then reanimate. 205 is right about here. Okay, it looks like, yeah, it was just a little bit short. Let's go ahead and add some more flow. So what I'm going to do is go up to edit and then unsteady flow data. Now I'm going to save this file as, let's just double the flow. I'll say 100-1000-100. And as you may suspect, I'm just going to double all the values in the hydrograph here. So I went over to Excel and I copied the values onto the clipboard. Now I'm typing Control V, and that should update the numbers here. Yes. Okay, so I'll click OK, and then File, Save Unsteady Flow Data. All right, so I'll click Close. Now let's go back to run the simulation, which I have open right here. Again, geometry files one pump. This time the unsteady flow file is doubled the flow. So I'm going to go File, Save this plan as, and then now it's going to have this plan name instead, and then OK. And then the short ID is right there. All right, File, Save Plan. Everything else looks good here, so I'll click Compute, and we'll see what we got. Okay, so I saw some red warnings, and I believe, let me just check that real quick. View, and then summary, error warnings, and notes are right here. And what it's telling me is basically the velocity head has changed more than half a foot. I believe that's between cross sections. So it's telling me that I may need to add some more intermediate cross sections. So that's fine. These are just warnings, not errors per se. And it's probably a good thing I should probably do. But before that, let's go ahead and take a look at some of the results here. View, summary profile table. This time I'm already on the pump station, but I want to add all the profiles or all the time periods. Now it looks like we do have some pumping happening, and it is close to 80 CFS, which is what I suspected. So as the water surface increases up to 205, which is right here, 204.99, pump kicks on, and then it pumps down to, what do we say, 203. So I'm going to click on pump station. Remember what I typed in here. Yeah, 203. So 205 down to 203. Let me close that. Go back to the results. So once the water surface elevation got down to 203, as you're seeing here, the pump turned off, and it looks like it may have turned on again one more time. I'm not sure about that. So the water surface elevation in the channel continues to recede. Okay, let's go ahead and take a look at the results, cross-section results. So I'll go View, Cross Sections, and this is at River Station 100, that cross section. So let's go ahead and do the animation. I like this. Click the play button and it turns on. Okay, there's the pumping just turned on, and then, okay. I'm actually curious about what it looks like at River Station 0. This is 100 feet downstream of the pump station. Options, animate, and then I'll go ahead and click this on. 205 is right here. Okay, that is a little bit more believable, I think. Next, I want to check out the hydrograph. So go View and then Stage and Flow Hydrographs. And what we have here is, let me turn off the flow. It starts off with the water surface is way down here at 201.5, and then it ramps up to 204.65, it looks like, and then back down. So it looks like the pump turned on right here, and then it looks like it turned off right here, and then maybe on and off one more time right here. If I wanted to add a second pump, I could do that by going to the geometry file. Once again, I'm going to go File, Save Geometry Data As. I'm just going to call it 2 pumps first. pumps. Okay. And then go ahead and edit the pump data. Come over here to pump group data. And as I alluded to earlier, I'm going to call this key 2. For the controls here, I'm going to call this 205 and 203. So the same on and off controls as pump 1. And then OK. File. Save geometry data. We don't need to change the flow data, so we can go straight to the plan, the analysis. And now the geometry file for 2 pumps is loaded in here. So I'm going to go ahead and name that plan. It's going to be named with 2 pumps this time. So I'll click OK. Then same here for the short ID. Everything else looks good. I'll go ahead and click compute and see what happens. Okay, I think we had the same messages as before, and these are just warnings. So I'll close that. Let's go ahead and take a look at the results for the pump station. So view, profile, summary table. This is the pump station. I'm going to go options, profiles, select all the profiles. And now we see we have about double the pumping capacity. We doubled the flow rate. It's no longer 83, 84, it's 167. But as you may notice, the pumping doesn't take place as long. It looks like it's only pumping for about an hour or 20. Whereas in the previous plan, where we only had 1 pump of the same power, it pumped for what, a couple, 2 or 3 hours, I think. And as before, with the same controls, the water surface is approaching 205. It's 205 right here. The pumps turn on, and the water surface elevation is back down to 203. So we should be able to compare the water surface elevation between these 2 plans. We had 1 pump and 2 pump with the exact same inflow coming from the River Station 200. I'm going to come up to View and then Stage and Flow Hydrographs. And then for the plans, I'm going to go Option, Plans. I'm going to toggle on 1 pump and 2 pump plans, which have the same flow right there. Click OK. Okay, this is a little busy. Let me toggle off the flow here in the legend on the right. I'm going to modify the symbology so I can see the lines a little better. This isn't too bad, I'll admit, but you can also go right-click, Lines and Symbols. So what I want to do is change the line thickness. Right now it's 1, but if I go 2, then it's a little bit thicker. And then I want to do the same thing right here. And then let's make that a 3 as well. And it's the same color, so let me go ahead and change it. The magenta is only the color when it's highlighted. So lines and symbols. Here's the line right here. I'll just make it, how about red? And then I'll click OK. All right, so here's just a little preview, and then click OK. So we have a red line and a blue line. The red line is with 2 pumps. It looks like it turns on and off a few more times near the peak. Whereas the blue line is with just 1 pump. It turns on, and I think it's on for a longer period of time. It turns off, and then I think on just for 1 more time period. All right. If I wanted to make any changes, I may want to actually change this computation interval to 1 minute and then see what the results look like. There's 1 minute right there. But I'm not going to do that. I'll leave it up to you to tinker around. There's too many things to try to fit into one exercise, but I hope this gave you a quick introduction as the first exercise I've done on this playlist with using pumps and running simulation and looking at the results in HEC RAS.